We will start into the new semester with a repetition course for organic chemistry. First subject we will talk about is the stabilization of reactive intermediates. So if we have a tertiary butane and let it react with a bromine radical, then HBr will be abstracted, hydrogen bromide. And where does that hydrogen come from? Selectively from the central CH group, and resulting then in this tertiary butyl radical. But what factors are stabilizing this radical? Well, first factor is the release of steric strain. Since those methyl groups are bulky groups that interact with each other, here they are more close to each other compared to here. Here we have bond angles of 109 degrees, here we have 120 degrees. It's important to notify that this molecule is planar. Here we have an sp3 hybridization, this one is sp2 hybridized. It makes sense to draw that including the orbitals. So we can do that. Let's say this CC bond is in the plane of that whiteboard, and we have a methyl group behind the blackboard, and we have one methyl group in front of the blackboard. Here we have a p orbital with one electron, and well, this carbon is sp3 hybridized, so let's introduce an sp3 hybrid orbital, and then we have an overlap to the s orbital of that hydrogen. Overall, 2 electrons are involved in this CH bond. And now those orbitals are close enough to each other that a slight overlap can occur here. There will be some electron density here in between. And this is the core of the hyperconjugation. We can draw that in some kind of mesomeric structure. So here, the one with the central radical. If this interacts with this CH group, and it can only interact with a CH group where the bond is perpendicular, parallel oriented to that p orbital. So only to one of the 3 CH bonds there is the hyperconjugation. Well, hyperconjugation to this hydrogen means, well, we can draw such a structure with a double bond here and a hydrogen radical here. That is, symbolizes a hydrogen atom, but be careful, there are no free hydrogen atoms involved here. All those mesomeric structures are not short time situations. No, the truth is in between. What does this mean? We have hyperconjugation to this one. Then we have hyperconjugation to that hydrogen here. We have hyperconjugation to that CH bond, to this one. So this is at the same time to some degrees, and it means that this bond here is more strong, it is a bit shorter. We have a bond order of more than 1, maybe 1.1. On the other hand, the CH bonds here, this one, and that one, are a bit elongated, they are weaker. We have a bond order of maybe 0.9 and not a full single bond with a bond order of 1 between the carbon and that hydrogen. So let us compare that to the situation at an allylic system. Here the bromine atom will abstract a hydrogen from the allylic position, forming the hydrogen bromide and this radical. And here we have a stabilization by real conjugation, mesomeric structure. Here is the mesomeric structure to that one. This is a very strong stabilization. So in this mesomeric structure we have a double bond here and a single bond there. Here we have a single bond there and a double bond there. So what is the bond order? In reality, for both CC bonds, it's symmetrical, the same bond order. Not 1, not 2, but in between it's 1.5. Thanks for listening.